Okay, let's do some samples here. I think these are off of your study guide. So what we're going to do is we're looking down here and we want to find out A, B, and C. Well, we're given A. They tell us it's 0, 0. We're also given B, 2p and 0. We're given a piece of C. We're given that the distance, this right here, is Q. Okay? So the vertical height from the x-axis to C parallel to the y-axis, let's put y on here so we know where we are. This is y. Parallel to the y-axis is Q. Now, what they're asking for is, what is the x value of C? Well, what do we know about an isosceles triangle that is dropped? We drop a perpendicular bisector onto the base. How far is it from A to B along the x-axis? 2p. So this distance right here, the whole distance right here is 2p. Then what is this distance right here? Divide 2p by 2 and you get p. So how far is it from the y-axis to C along the x-axis? It's just going to be p. Okay? Looks just like that. Alright? So that's that one. Well, let's look over here. We're trying to find E, F, and G. Okay? Let's put down what we know. E, we don't know anything over there. Okay? F, we don't know the x, but they're telling us that this distance right here, okay, along the y-axis is B. Okay, so we know that. So this right here is B. Now, they've given us everything for G. It's on the x-axis, so the y is going to be 0, and it's 2g away from the origin right there. Alright? Well, what do we know about this base? The y-axis acts as a perpendicular bisector from the vertex angle to the base, doesn't it? That simply means that this is going to be equal to that, isn't it? Where is E? How far away from the x-axis is it? It's not away from the x-axis. So what is our y going to be here? That's going to be 0, isn't it? If G is 2g away from the y-axis, E is going to be 2g away, but it's on the what side? What's the sign of x over here? It's negative. So this is going to be negative 2g. Okay? Now F. What's the x value of F? Well, how far off of the y-axis is it? Well, let's put our y up here and our x here. Well, it's right on the y-axis. So what's our x going to be? If it's right on the y-axis, then our x is going to be 0. Okay? Look at that and study those. We're going to be doing 2 or 3 more. And these will be a little bit different, given a description, graph them. Okay, on these 2 samples, what we've got is we've got a description of a triangle, and we're going to graph it. We need to use these steps. Description of a couple of triangles, and we're going to use these steps to graph it. Okay, what we've got is we've got an isosceles triangle, RST, with base RS that is 4 units long. Well, number 1, use the origin as a vertex or center of the figure. We definitely want to do that. Place at least one side of a polygon on an axis. Keep the figure in the first quadrant if possible. Let's see if we can do that. So we've got RST with base RS. So the vertex angle is T, isn't it? Okay, so the base is RS. So let's put R right there. And let's put S right there. Now, segment RS is how long? 4A, isn't it? Okay? Well, the vertex angle is going to be about halfway. Not about, it's going to be exactly halfway, because if we drop a perpendicular bisector right there, that makes that equal to that. We already know that these two are equal. This is going to be T. Oh wow, one of these sides is going to be what? 2A, and this is 2A, isn't it? Okay, let's do it. R. Oh wow, R is on the origin, isn't it? 0, 0. S. What's its Y value going to be? Well, it's on the x-axis, so it's going to be there. How far is it from R to S? Well, it's 4A. Okay? Now, T. Where's it going to be? Up here? We're just going to assign that a value because we could figure that out. But we're going to assign that a value of B. Okay, it's B high, so we're going to assign this value just a value of B. But how far is it along the x-axis? It's 2A. So that's how we would do that one. Notice that number 1, we use the origin as the vertex or center of the figure. Okay? We placed at least one side on the axis. We placed the base on the axis. On the x-axis. Keep the figure in the first quadrant. We kept everything in the first quadrant, so all of our numbers are positive. Okay, let's look at the next one. Isosceles right triangle DEF with legs E units long. Got a right triangle. Wow, where would you like to put that right triangle? Use the origin as a vertex or center. Place at least one side of a polygon on an x-axis. Keep the figure in the first quadrant. Make it as simple as possible. Wow. If I've got a right triangle, I could put two sides on the axis, couldn't it? I could put one of them on the x-axis and one of them on the y-axis, couldn't I? All right? Isosceles right triangle DEF with legs. Didn't tell us what the name of the legs are. Do we know where that DEF is? No, we don't, do we? Well, the legs are E units long, so probably let's make E the vertex. So I'm going to put E at the origin. So it's going to be right there. Okay? Now, if that's the vertex angle, then this is a right triangle, right? I'm going to go this way, E, and I'm going to be putting a D right here. And I'm going to go this way up here. You tell me when to stop. That's going to be a little E. This is going to be a little E. This is going to be congruent to that. And this is going to be an F, isn't it? And I'm going to put this like that. Okay, so what's the coordinates of E? Well, that's easy. That's 0, 0. How about D? Well, how far is D from E? E and vertical, it's a 0. How about F? How far from E along the x-axis is F? Well, it's not. How far from E is F along the y-axis? Okay? So how we place these things on the coordinate grid makes a big difference. We could stick it out here in space. Okay? But then that means what? We've got to move that thing. We've got to add some extra stuff to it. We could stick it out there and put it over here. That wouldn't be too hard either. We did an example like that. We could do it several ways. This appears to be a very simple way to do that, and it obeys every one of our rules. Use the origin as a vertex. Put at least one side on an axis. Well, we put but two sides on the axis. Keep the figure in the first quadrant. We did that, and we made it so that the computations were as simple as possible. Have one more we're going to do, and then we'll be done with this chapter. Ready to test on it on next Wednesday. Okay, this is the last one. This one's a little interesting because we're actually going to prove all these points and show you how to prove these. Honor students, you ought to take a little hint on this. You might see some of this later on down the road. All right, so let's look at this. On this one we have an equilateral triangle, triangle EQI, with vertex Q, and it's there. And sides 2b units long. So let's put Q where it needs to be. Q is X is the X is 0. So where does that put it? That puts that on the y-axis, doesn't it? Interesting. So let's just stick OQ up here. We're going to say it's there, and how far up is it? Well, they tell us it's b square roots of 3. Okay? And it's an equilateral triangle, so let's try to make it as equal as we possibly can. See if we can do this. Okay. Let's put E over here. Does it matter where we put E or I? No, it doesn't. How far is this right here? Well, this distance right here from here to here is 2b units. This is 2b units. This is 2b units. Okay? Got it? Well, how far is this right here? Well, this is b square roots of 3, isn't it? Okay? Well, tell me something. How far is this right here? This little piece right there. If this whole thing is 2b units, we know that perpendicular bisector drop from the vertex angle to the base does what to this thing? Cuts it in half. So this right here is b. What's this section right over here? This is b. Add them together, you get 2b. Okay, you ready? They gave us that. So let's come down here and do I. Oh, let's do E first. From the origin, how far is E from the origin? It's B. On the x-axis, how far from the origin is it along the y-axis? Well, it's on the x-axis, that's got to be 0. Well, I is on the x-axis also, so that means that's going to be 0, right? How far away from the origin is it? Well, it's b away, but we're headed in which direction? Negative b. Now, let's play with something. I'm going to take this and I want to take this. We know this right here is what kind of angle? Right triangle. So we have a what right here? We have a right triangle. What theorem can we use with right triangles to find sides? C squared equals a squared plus b squared. Well, we have the hypotenuse, which is this one. If we square that, that's going to be 2b squared equals, we have this side, but we don't know this side. Let's play like we don't know that side. We have b squared plus some unknown x square x. Okay? Oh, let's put x squared there. So, what do we get here when we do this? Let's square this. Square everything inside. That's 4b squared equals b squared plus x squared. Okay, so let's subtract. B squared minus b squared. Where do we end up? 3b squared equals x squared. But we really don't want x squared, we want x, don't we? So let's take the square root of both sides. Well, shucks, what's this here? Well, we know what the square root of b squared is. It's b. So x equals b square roots of 3. Wow. So this right here is the actual position of Q along the y-axis based on the information given to us. Okay, and how do we prove that? Using Pythagorean theorem. Welcome to special triangles, right triangles, and special relationships among certain right triangles. Okay? Study that one. You're going to see it again and again and again. If you ever take a test over geometric, ACT, SAT, you'll probably see that on the math section and need to use it. That's all of chapter 4. We're ready for a test.